Hello everyone and welcome to another simple science video, and in this video we're going to be looking at carboxylic acids in our IGCSE organic chemistry series. So carboxylic acids are just another type of organic molecules in IGCSE chemistry, and they are just another type of homologous series. They are inherently acids, and just like how we analyzed and studied organic molecules, we're going to be looking at carboxylic acids groups with special regard to its functional group, and this functional group of the carboxylic acids is known as the carboxyl functional group, and it is responsible for the reactions and the properties of the carboxylic acid. Okay, and this carboxyl functional group is the COOH group that I've highlighted here. It consists of two oxygen atoms and a hydrogen atom, and all of them are bonded to a carbon atom. So these two oxygen atoms are bonded together differently in that one oxygen atom is double bonded to a carbon atom, and another oxygen atom is bonded via a OH group to that same carbon atom. Okay, so let's look at the general formula for this type of organic molecule. So I've isolated the COOH functional group separately in this general formula, so it's much clearer. So as a result, the general formula is Cn-1 H2n plus 1 COOH, whereby n is the number of carbon molecules, and COOH is again identified separately. And just like any other organic molecule, the name of the molecule is based on the number of carbons within that molecule. So we have methanoic acid of 1 and butanoic acid of 4, for example. And just like any other organic molecule, there are versions of it, such as branches, multiple branches. So in this case, we have a methyl branch attached to a main carbon chain of a propanoic acid molecule. So we have the name of this molecule as methyl propanoic acid. So as I said before, the carboxyl group, functional group of the carboxylic acid, is responsible for the properties of the acid and also the reactions. So let's first look at the physical properties of this type of organic molecule. So it has a high boiling point, higher than most other compounds of the same number of carbons. So this is generally responsible. What is generally responsible for this is the hydrogen bonding, which you will learn later at A level. Okay, and that's responsible for the high boiling point that keeps these molecules together. In addition, they're also very soluble, and this is also due to hydrogen bonding, which is responsible for its solubility, specifically in water. But this solubility does decrease with size, or in other words, the carbon length or the number of carbons, or just generally the molecular mass of this molecule. Okay, so this functional carboxyl group is also responsible for the reactions of carboxylic acids, and the types of reactions that the carboxylic acid can undergo predominantly is, first of all, acid reactions. They are acids inherently, as implied by their name, and another type of reaction known as esterification. Okay, so let's first look at the first type of reaction known as the acid reaction. So carboxylic acids are inherently acids. They are very weak acids, however. They only partially dissociate into ions. Okay, so that results in a pH of less than 7. So nothing compared to the very low pHs of acids such as strong acids such as hydrochloric acid or sulfuric acid. So in other words, they only partially dissociate into ions. So we have this on top, the carboxylic acid molecule, and they only very partially dissociate, as implied by the equilibrium icon, which shows that there are two possible states in which this carboxylic acid can exist. So as a full molecule, or dissociate into a negative, in this case, ethanoate ion, and a positive hydrogen ion. Okay, so that just shows the partial dissociation of this organic molecule. So acid reactions. What kind of acid reactions do they can take place? So carboxylic acids can undergo the same types of acid reactions as pretty much any particular acid. Okay, so in this case, we have an acid reaction of ethanoic acid and a metal, so in this case potassium, and as a result the product that is produced is potassium ethanoate, whereby the negative ethanoate ion from the ethanoic acid combines with the positive potassium ion, and that forms the potassium ethanoate substance, and also produces hydrogen. Okay, and it can also undergo other types of acid reactions like normal acids, such as reacting with bases such as oxides to form a salt and water. So we know an acid can react with the bases to form salt and water, and also reacts with a carbonate to form salt, water, and carbon dioxide. So just like how sulfuric acid or hydrochloric acid may react with calcium carbonate. Okay, so it is an acid basically. And the other type of reaction that it can undergo is esterification. In other words, the production of esters. Okay, and this is basically when a carboxylic acid reacts with an alcohol. So the product of this reaction is an ester that basically has attributes from both the ethanoic acid and the alcohol. So this type of ester gets the carbon chains from both the ethanoic acid and the alcohol, whereby this name is propyl ethanoate. Why propyl? Propyl comes from the number of carbons from the alcohol side, and ethanoate comes from the number of carbons on the ethanoic acid side. Okay, so what happens in this reaction is that from the carboxylic acid, an OH group is removed, and from the alcohol, a H group is removed. So as a result, what is left will combine with each other to form an ester of propyl ethanoate, and the what is removed is combined with each other to form water. Okay, so when a carboxylic acid reacts with an alcohol, it produces an ester and a water, and ester is that type of combined molecule shown there. Okay, and an ester contains a COO functional group as highlighted there. So this is another type of organic molecule, and they're very easily identified by their, they smell very good. Okay, so esters are used prominently as perfumes, or they can be used as solvents. Okay, so I've covered carboxylic acids, the theory, and types of reactions they undergo, the products. And if you have any particular questions or any types of videos that you want to request, please feel free to leave them in the comments, and I'll try my best to make it up to you guys. And I wish you guys the very best in your revision and in your studies. And see you again very, very soon.